A balloon is inflated to room temperature. So if the Celsius temperature is doubled, what will happen to the volume? Now, if I'm looking at changes, okay, volume and temperature are directly proportional. Okay, that means that if V goes up, T goes up, and if V goes down, T goes down, and vice versa. Okay, so remembering temperature in kelvins, always. Okay, so let's see what happens if I increase my temperature by doubling the Celsius temperature. Let's see what happens with the Kelvin temperature. So I'm just going to pick some numbers. So if I say my first temperature is 20 degrees Celsius, that means that my Kelvin temperature here is 293 Kelvin. Okay, so if I double my Celsius temperature, let's say I double it, and it becomes 40 degrees Celsius. When I convert that to Kelvin, that becomes 313 Kelvin. Not doubled here. Okay? So the size of a Celsius degree and the size of a Kelvin degree are the same, but they're offset by 273. So doubling the Celsius temperature does not double my Kelvin temperature. Okay, and kelvins is what we're concerned with in this chapter. So if I will increase my temperature, but I don't double it. Okay, so whatever happens to the temperature affects the volume. They move together. They're proportional, directly proportional. Okay, so will my volume double? Not unless my Kelvin temperature doubles. The balloon's volume will increase a little. That's probably true. The balloon's volume will decrease. Not if I'm increasing my temperature. Direct proportional means that if temperature goes up, volume also goes up. The volume will decrease by a factor of 1/2. It won't decrease at all. And the balloon's volume will not change. It must change because volume and temperature are directly proportional. Okay. 24. A propane tank at a temperature of 0 degrees Celsius has a pressure of 415 psi. At what temperature Celsius would the pressure in the tank increase to 635 psi? So helpful thing is to make a list of what we have. So I have a temperature 0 degrees Celsius. And we'll just automatically convert that to kelvins, okay? And then we have a pressure of 415 psi. And then at what temperature, what new temperature, so T2, we don't know, will the tank pressure increase to 635 psi? So P2, 635 psi, okay? So the things that are changing are temperature and pressure. So we're going to come back to the P1 V1 over T1, P2 V2 over T2. But my volume isn't changing. I'm just dealing with this propane tank. So the volume inside that isn't changing because the size of the tank isn't changing. So again, we're going to drop out that V2 business. Okay? So I'm going to solve for T2 here. All right? So we do a little bit of algebra foo, and we're going to rearrange this guy, and it becomes P2 T1 over P1 equals T2 in kelvins. okay? And the question wants the temperature in Celsius, okay? So now that we have our equation rearranged, we're just going to plug in our numbers. So we'll have 635 psi times 273 Kelvin over 415 psi. And we'll find that that equals 418 Kelvin. Question wants things in Celsius, so we say 418 Kelvin minus 273 gets us to 145 degrees Celsius. Okay, gas with an initial pressure of 780 torr. So we have a pressure, 780 torr, and a volume of 150 liters. Is compressed to a new volume of 30 liters. The temperature is held constant. What is the new pressure of the compressed gas? So P2 is, we don't know. Okay. So we look, and the things that are changing are the pressure and the volume. Temperature is being held constant. So I go to my equations and I look, I've got one that says this, with pressure and volume being the two things that change. And I want to solve for P2. So P1 V1 over V2 equals P2. Okay. So 780 torr times 150 liters divided by 30 liters gives us 3,900 torr. A balloon is inflated to an initial volume V0. So V0 is just a starting volume, and we don't really know what the number is. And it's sealed at room temperature. At constant pressure, if the Kelvin temperature is halved, the final volume will be what? So volume and temperature, we already talked about this, are directly proportional. Right? So as V changes, or as T changes, V changes. So if I cut my temperature in half, I am also going to cut my volume in half. Okay, so in our equations, we have this relationship, right? 2T2. That means that these are directly proportional. Right? We've said this a couple of times now. We also have the relationship of pressure and temperature. Okay? So if V over T is directly proportional, P over T is also directly proportional, but P times V is inversely proportional. Okay, so as volume goes down, pressure goes up, or as pressure goes down, volume goes up. They move opposite. Okay, so let's think about what we have in this question. So we have an initial pressure of P0. and the Kelvin temperature is doubled. So if I double my temperature, that equals double my pressure. Okay? Because P and T are directly proportional. But if I double my volume, that means that I cut my pressure in half. Okay? So if I double my temperature, I double my pressure, and then if I double my volume, that cuts my pressure in half. So in the end, I haven't changed anything at all. Okay? First I double it, then I cut it in half, so I'm at my starting point. Okay. Question 28, I skipped because I think that it is actually incorrect in some way or something, but I wanted to just skip right over it because it really isn't anything terribly useful for you. Nine. A gas at 22 C. So it's nice to make lists. Has a volume of 1.25 liters. Is heated to 44 degrees C. So I have a T2 now. At constant pressure. And it's an important part. What will the new volume be? Okay, so I've got a T1, a V1, and a T2 and a V2. Pressure is constant. Okay, so we will have V1 over T1 equals V2 over T2. And we want to solve for V2, so we find out the V2 equals V1 T2 over T1. Okay, and remember our temperatures need to be in kelvins. So plus 273 makes that 295 Kelvin. My other temperature, 273, 317. Okay, so now that I have my temperatures in kelvins, I can plug them into my equation and solve away. 1.25 liters times 317 K over 295 K equals a new volume of 1.34 liters. Okay? The important thing here is to be able to recognize what's changing. Things that are changing are the temperature and the volume. Okay, so that's why I want to choose an equation that has changes in volume and temperature.